Hi, and welcome back. Today we are going to move on and do a different maths topic. Today's maths topic we're going to start is area. We're going to do a few videos on area, and each day it's going to get a bit more difficult, but today we're going to start off with what is area, how to find area of simple shapes, and also a little bit difficult as we're moving through stage 3 is how to find the area of shapes where some of them have decimal places in them. Okay, so when we're doing area, sometimes we get a little bit confused between perimeter and volume and area. So let's go through the difference between all three. When we have perimeter of an object or of a shape, or it could be like a farm, we're looking at the distance around the outside. Okay, so if you're measuring how much fence you were going to need to put on a farm, how much of the wood you were going to need for the fence, you'd be looking at the perimeter because it just has to fit around the outside of the shape. So when you have that outside of that shape, it might come up as 4 centimeters, which is the length around the outside. You could just use a ruler. When we're looking at area, we're looking at how much can fit inside the shape, inside the surface of the shape. Okay, and what we're looking at there is we're looking at centimeters cubed. Centimeters squared, sorry. And what I mean by that is how many of these little 1 centimeter by 1 centimeter blocks can you fit into that shape? Okay, because that's why they say squared, because it's 1 centimeter by 1 centimeter square. How many of those squares could you fit inside the shape? Okay, and then if we have volume, we have how much could fit into the whole shape in a three-dimensional shape. And what we mean there is how many 1 centimeter cubes could we fit. So that's why it has a cube with a 3 after it, because it's basically how many cubes, 1 centimeter by 1 centimeter by 1 centimeter cubes, could you fit into that shape. Now when we're solving volume, you might see length times height. I mean, a lot of different sometimes letters are used in the formula for area, but we're going to go with width times height. So this one here, how far across here, and we times that by how the width of the shape and the height of the shape. We times those two together and we get the area. And we need to make sure we always put it with the squared, because how many of the squares fit in them? Now that might be meters squared, centimeters squared, kilometers squared. Geez, a kilometer squared is a big area. But if we're measuring the size of New South Wales, we definitely need to use those units of measurement. So let's go through and go through a couple of them to see how it works. Okay, so let's look at the first one. We can see the height of this shape is 4 centimeters and the width of this shape is 10 centimeters. So it's just as simple as going 4 times 10 equals 40 centimeters. Done. Well, not yet, because if you were going to give this to me in a test, I would give you half a mark. If you're not going to put in the squared after the centimeters, you will only ever get at least half of the mark that you need. So you need to make sure you're putting in the 40 centimeters squared after it, otherwise you're not doing the full answer. In example number 2, we can see the height is 4 centimeters and the width is 5 centimeters. So it's 5 times 4, sorry, it's hard to reach across this far, is 20 centimeters squared. Now, if you were wondering whether that's how that actually works, I'm going to do a really bad job of this, but just stick with me. If you were going to have 4 centimeters like that, and it was going to be like that, it's bad drawing, but let's say they were all even. So it's 5 centimeters across and 4 centimeters up. Inside you count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. It's exactly the same. So if you were going to cut it into 1 centimeter blocks, it would be the exact same amount. All right. Now we're going to move on because we're in stage 3 and this is actually stage 2 work. So we're going to move on to what happens if you get to a shape that has decimals in it. Okay? It's really important when you're solving a shape with decimals in it, there's a really quick trick, and that is to not get confused by the decimal places. What you need to do first is you need to pretend like the decimals don't exist. Okay? Let's use this as an example. If you're good at multiplication, at doing algorithm, you'll be really good at solving decimals. So let's write it down like this. Okay, we're going to write it down with the decimal places, but we're not going to worry about them. Okay, we're not going to worry about them at all. We're going to pretend like they don't exist, okay? So 5 times 5 is 25. 5 times 3 is 15, plus 2 is 17. Second row, I put the 0 here. 2 times 5 is 10. 2 times 3 is 6, plus that is 7. Then you plus down, which is 5, 7, 8. Okay, but we're not finished there because there's no way 2.5 times 3.5 is 878. This is the thing. You don't worry about the decimal places, and then at the end, you see how many places are there after the decimal places. Ready? So there's 1 here and 1 here. Okay, that means you need to go back 1, 2 spaces. However many digits there are after both of the decimal places, you plus them together and you go back. I know it's confusing. We're going to go through it together as we go. So it's 1, 2. So you go back 1, 2, and put a dot, which means the answer is 8.75, I guess it's centimeters, squared. I'll give you another example. Let's do 2.5 by 6. Okay, so it's 2.5 by 6. We're going to pretend like the decimal doesn't exist. 6 times 5 is 30. 6 by 2 is 12, plus the 3 extra, it's 15. And we look, how many places were there at the end after the decimal places? Well, there's only 1 with a decimal, and it's only 1 number, which is there. So we only have to go back once. So it's 15. 15 centimeters squared. This one's a bit harder because both of them have decimal places again. So we're going to write it down. 3.5. Oops, sorry, bad. 5.5. I feel like I'm not going to have space for this. I'm going to have to write about this. Okay. 3.5 times 5.5. Solve it like a normal thing without them being there. Pretend like they're not there. 5 times 5 is 25. Put the 2 up here. 5 times 3 is 15, plus the 2, 17. Next row, put a 0 first. 5 times 5, 25. Put the 2 up here. 3 times 5 is 17. So 3 times 5 is 15, plus the 2 is 17. Now add it all down. 5, 7 plus 5, 12. Put the 1 up here. 7 plus 2 is 9, plus the 1 there. Now we need to count, when we had the decimals, how many digits were there after the decimal places? 1, 2. So we need to go back twice. Start from the end, jump once, jump twice, put a dot. 19.25. I'm pretty sure it's centimeters squared. Okay? I know this is a bit difficult, and I know it's really hard when we're not in class to go through it with you. Okay, I understand that. If you can do if you're in year 5 and you can do these ones here where they've just got simple shapes, shapes without decimals, and you can do all of those, that's great. That would be all you would need to do in year 5. I'd really want some of you to start pushing up to this level in year 5. And if you're in year 6, I really think this is necessary. Multiplying decimals is going to be really necessary, and I think I've explained it well, but I'm happy to go through it in another video later this week. And this last video here, don't be confused. If you don't know how to do this, that's fine. I'm just putting it in there so that other people who want to try to extend themselves can have a go, but don't get stressed out if you don't know how to do this one, okay? So it's 4.25 by 5.75. Even I'm getting worried about this one. 4.25 by 5.75. I've got to turn my chair around a little bit. And now it's just simple of going through 5 times 5 is 25. 5 times 2 is 10, 12. 5 times 4 is 20, 21. Next row 0. 7 times 5 is 35. 7 times 2 is 14, 17. 7 times 4 is 28, 29. Then the next row you do 0, 0. 5 times 5 is 25. 5 times 2 is 10, plus that is 12. 5 times 4 is 20, 21. Oof, starting to get confusing now. Can't even read my own writing. That's a really good sign. Okay, plus that down is 5, plus that down is 7, plus those down is 12, 13, plus those down is 10, 14, plus that, wait, plus that is 4, plus that is 2. I think that's right. I think it's right. Anyway, the main thing is that with the 5 point, you look at how many decimals there were after, how many digits there were after the decimal place. 1, 2, 3, 4. So you go back 1, 2, 3, 4. 24.4375 centimeters squared. Please don't be confused by this. If you understood that, then that's what you're up to, that's great. If you want to push yourself up to this level, that's great. This is just here as an extension thing, so don't get confused if you don't understand how to do this. But I want you to understand at least what you would have to do, even if you can't solve sort of 3-digit by 3-digit multiplication. At least understand that when you're doing solving by decimals, if you pretend like they're not there and just solve it as 35 times 25, and then just go back once, twice at the end, and then you'll be able to do that. So there's a few things. Firstly, the rule for area is width times height. Secondly, when you're solving it, you need to look at the centimeters, meters, kilometers. Thirdly, you need to make sure you're using your squared thing here, otherwise you won't be marked correct. And fourth, if you're using a decimal place, pretend like it's not there, solve it normally, and then go back however many digits, 1 or 2 or 1, 2, 3, 4. Okay? I hope that's helped. Tomorrow we're going to look at composite shapes, so shapes that look like this, and how to break up those shapes and solve the area of those shapes. I hope that's been helpful. Like I said, please don't get confused. If you got up to this, then just do the worksheet with those ones. If you got up to these ones, you want to try to push yourself, there'll be questions like that for you as well. All right? Thank you for watching.